Hello, I'm your interviewer today. And
Hello.
hi, I'm going to give you a question. And the question you can see are given an m times n to the binary grid, which represent a map of ones and zeros. Return the number of islands. An island is surrounded by water and is formed by connecting adjacent land horizontally or vertically. You may assume all four edges of the grid are all surrounded by water.
Uh, Also, my understanding is that I am given a map. A map is a string with new lines like this. And this will form something like this. So in this example, there is one island because it was connected horizontally with another tile below. And another example will be this. This will form two islands because it was not connected adjacently. It was connected diagonally. So it was connected where the tile was the left and bottom tile. So this example return 2.
Oh, yes, your understanding is right.
Also, let me check something. For example, in the first example, I have give a tiles which is not square. We have 4 tiles, and in the first row we have 3 tiles. In the second row, we have rather 3 but 1 tiles only. So, is this the case for this problem?
No, it will be if the first one will have 3 tiles and the second row will have the 3 tiles too. It's a m plus n times n to the binary grid.
I would like to know if there is any range limitation. For example, the n will be limited to to 100,000 or something, or 10,000. What's the maximum value of n and n respectively?
Oh, the limitation is 1,000.
Okay, so I think my approach will be that either it's just some form of map or some form of graph, and I need to find all connective components for that graph. So first, I will take the input string like this one, representing the binary grid. Then I will encode the binary grid into a bidirectional graph. Then I will use BFS to search for all connected component in there. And if there is 3 connected components, I will know that there is 3 islands for this grid. So is the approach correct, or am I missing some edge case?
I think your approach is right.
Okay, so let's next go to the function signature. So may I type the function signature to make sure we understand the input and output for this problem?
Yes.
So I will write something like a number of island. And it will take a string which might contain some new line if there is multiple rows. So this is tiles. And it will return number. So for this problem, there's at most 100,000 anyways, just 1e6 at most this output. So using the integer should be okay. And first, I will need to encode the tiles into a connecting T graph into something like adjacent table. So I have to let me use STE. And I use site here because site is means the path from wide. For example, you are 64-bit path forward, so it should be easier to adjust. Let me call it. Oh, this just call it graph, and the graph is an adjacent table. I would need to initialize the graph to all empty vector, so it means all tiles are not connected to each other because we actually encode the tiles into it. So maybe I wrote too much ROS for that reason.
It's okay. It's okay.
And graph, yeah, push back. I need to initialize the item on stack. Oh. So that way we have initialized the adjacent table. Then I have to search for tiles. Before we search for tiles, we may find n first. So let's call it wide 等于equal 0. I will try to find a new line. May I ask one additional question? For example, if I have tiles like this, will be the trailing character new line or will it not?
Not. Will not have a.
Also, if there is n equal 3 and n equal 1 tiles, there will be only 3 characters and one neo terminated character in the end. So is it correct?
Yes.
Okay, then I would just make the iterator, use the iterator to try to find the end of or the new line of tiles. So this way we have specifically find the width. Then I have to use then I have to also find height. So I'm passing one on width because there is a new line, and I'm passing one on size because the trailing character was not new line. Culture has some bug on scaling. Okay, it worked. Then I will to iterate all the slots. So first iterate wide with I, and I, while I is less than width. And in learn 2, I will iterate over height using J. And in here, I will check if the tiles has any adjacent kinetic graph. So if I let's first write the lambda function for checking if the graph is connected. So check, let's call it slot, check slot the lambda function, and CICJ, and we'll check if the value was 1, and also we will check outside the lambda function if the slot now we are correctly checking for. So it's the tiles ij will be 1 if the tiles ij is water. We don't need to connect it to anything. So iterate equal. Oh, where's the equal? And this way it should work because it will overflow. We are using size t. And if tiles ci plus cj multiply width plus 1. In outer, we will check if tiles I plus j multiply width plus 1 equal character 1 or equal 0, then continue. Otherwise, we'll check every slot. And because it overflow, we only need to check. For example, if the I was -1, it will overflow and become a large number of size t, and it will definitely be larger than height, so it will return false. So that way we could then modify this function to build a adjacent table. So if it was returned true, then we build the adjacent table to connect those two graph. Okay, let's use the indices. Let's use the indices and don't pass 1. So until here we have successfully built a graph, so it's a JSON table. And I have to write the BFS to check if every tile is connected or not. So and I correct all until here.
Yes.
Okay. So to build the kinetic component with BFS, first we need to keep a velocity vector with boolean to indicate if it's velocity. Then have to velocity the every ID from 0 to the maximum number and check if it's velocity. If it's velocity, then I will skip the tile. And if it's not velocity, I will code it if it was connected to the last tile. So let's get started. So I will first create a vector. So the vector should be in the length of graph dot size. Then you will initialize to false value. Let me recall. Okay. And I will iterate. Let's first use kinetic component. And so we only need to know how many are connected or how many connecting components in other words. So we don't need to hit a two-dimensional vector for that. So let's put a variable kinetic for that. So first, let's check if it's connected. So if it's visited, then let's continue. And if it's not visited, we have to mark it as visited. Then we have to have a for loop or have a while loop here for the BFS. First, we need to create a queue. Oh, maybe I forgot to skip something. Oh, it's not connected, so. Okay, I have to check if the I was equal to 0. If it was equal to 0, let's don't check it. Kinetic component +1, and while Q点 is Q点. Let's pop the top of it node equal Q 点 top of front Q 点 pop. And then I will check the kinetic children. So that's T equal graph 点 graph node children. 然后I will have to make sure those children are also visited and push it into the queue. So for child in children. Push it to the queue. And we will be visiting then. Oh, so let's just return. Okay, I think I have finished most of that, and let me check and run a test to ensure it's correct.
Okay.
So so let's follow the naming convention. That's a straight naming convention. And in paste back. If it was 0, let's skip it. I'm missing something. Missing a parenthesis for the size function. Parenthesis. Empty. So it's so I think my code is correct. Then may I run a test for that?
Okay, it's
Okay, so let's have a more complex example. So the example here we will use, we need some amount of kinetic component to see and test the effect of a Jessie table. So I will use this test case. So for this test case, the string will have size of let me think 11. So I will check tiles equal size. So this is incorrect. So I have to first check for width, then continuously initialize a graph with length of width multiplied by side height. So that's correct because we have new line in the input string. It's not going to work. And maybe the input string we should put a reference here. And so now we have the graph of 9. And we will build a graph by skipping any tiles that's 0. So let's check first if I equals 0 and j equals 0. I equals 0, j equals 0. It will check for the over 40 byte in left. So the byte was supposed to be here, but it was overflow. So it was greater than width. So it gets skipped, and also so this slot here is also getting skipped. But this law is valid. So check if it was 1. So for this example, it was 1. I will correctly plus 1 here. I will push to the graph indicating it was connected. Because it was bidirectional on the when I equal to 0, j equal to 3, and j equal to 1, it correctly connect back to the first one like this. So I think the graph will result in something like first is connected to the third, and the third is connected to the first and the fourth. The fourth is connected back again. And on BFS side, we will check if velocity is it was initialized to false, and I will have marked it to true. Okay, it was called callback. I guess syntax doesn't matter too much. And push back because we have a kinetic component. So this here we are missing something. we have some typo here. Okay, I think the code look fine, and I have run a basic test to ensure it works.
Okay, I think it's pretty good, and I want to ask you another question. Is the island now is in 4 direction? If now we think we change the yes, wait a minute. Yeah, and the island is 4 connected adjacent then horizontal and vertically, right? But now I want to change it to the A direction. Or A direction we will, if they are connect, I will name they an island. So what will you need to change your code?
I will need to change this part in particular. This part will have to check another for slot. So it was when it was not horizontally adjacent, but rather diagonally. So it should check for it also. It should also check for that.
Okay. Okay, thank you. Thank you for your time.